Okay, now we're going to look at a couple of concepts that are not covered in your textbook. Okay, remember our objective here is dimension reduction. So we want to get rid of variables that are not contributing sufficiently to the prediction process. One of the criterion that we can use is correlation. If the predictors are correlated within themselves, then we want to remove one of the two. And that is made easy with so here I didn't place the distribution bar correctly, so it should be here. All right. Now we want to remove highly correlated predictors. So caret function library has a find correlation function that will identify variable predictors that are correlated within each other, between each other, and then figure out which ones to remove to reduce the correlation. So let's get library caret activated. Okay, so now we have to first find the correlation of predictors, predictor.core, for example. Okay, we'll put the correlations in there. So we do COR for Boston DF, but we want only the predictor variable, so we need to put that in square bracket. And see the last three columns, the medv and cat medv are two possible target variables. Okay, we are only interested in figuring out which predictors we should keep and which ones we should throw out. And the last one, this is something that we created from RM. So 13, 14, and 15 are not needed. So within this square bracket, comma, minus C 13 colon 15. Okay, so that has all the correlations, right? So once we have the correlations, then we can figure out which ones to remove using the caret function called find correlation, right? So we can give predictor dot core, okay, and then we can specify a threshold value. Okay, so we can say we want say 0.75 or something. Okay. Now, of course, we want to capture that. So, what columns it's going to find? So, let's say high core. Okay. So now high core finds three of them, 3, 5, and 10 to be removed. So then we can say Boston housing less high core. All right. So then that would be Boston housing. Okay. All the rows minus C. No, not minus C. We have it already in high core. Okay, so that would remove. Okay, so we have removed three variables, and then we can put the medv, cat medv back in if you like. Now there is another tool that we can use for dimension reduction is to look for variables that have near zero variance. So for example, if a column has all the same values, then it does not have any predictive power with respect to predicting the target. So if all the values are the same, then the variance will be zero. So if any variance is very small, okay, then we want to throw those variables out. Okay, so again, caret has a function for that, and that would be, say, near zero var. Okay, so we're going to capture those, and the function is near zero var in caret, and then we give Boston housing DF, and once again we will remove 13 to 15. Okay, and near zero var is empty. So that means it has not found any variable that has very low variance that needs to be thrown out. Okay, if you do have numbers here, then you will do the same as before. You will remove them using a code like that.